This chapter we are going to study object-oriented design as a paradigm, but still we are looking into a low-level concept in a programming level. In high-level concept we are going to learn after this. So we have talked about this topic many times already, how to discover classes when problem description is given from the statement look for nouns is the first step to discover classes, but we already know that not all nouns will become class. Some of the key playing nouns will be classes, and then we are going to design. And then we can easily find the methods for the class by looking for verbs which takes action on the noun or from the noun. Those becomes methods or behavior of the object. So let's use an example. Suppose we are going to print invoice where we have a customer's address, and then we have itemized the list. So each line item we have a product name, quantity, and the unit price and the subtotal price, and then finally we have a total amount due. Suppose we are going to write a program for such invoice printing one, then we may find many nouns from the real problem descriptions, but we could have those three prominent nouns for candidates for classes like invoice, line item, customer, or we could have a product. So it is generally a good idea to keep a list of all candidate classes, but after going through brainstorming, then not all candidates will become actual class specification. So we will do some that kind of process later. So we have a CRC card method to find the responsibility of the classes. For another example, suppose you are going to write a class scheduling system, then potential class candidates from the description by identifying nouns could be class, lecture hall, instructor, and student, and many other things. So after you have a set of classes, now define behaviors, which is a method of the class. So look for nouns to find the behavior. So I go back to the first problem. We talked invoice program. Then we need to compute the amount due. Then which class is responsible for this one? So invoice is responsible to compute the amount due. Then the computing the amount due becomes a method or behavior of invoice class. So to find the class responsibility, we use a CRC card. CRC represent class responsibilities and the collaborating classes. The acronym is a CRC for that. Instead of using index card physically, we are going to use just a Word document that just create a table which is similar to index card. So here is an example. Index card name is a class name. Below that we have two columns. So first column we put responsibility. In the second column we list the collaborators to accomplish the responsibility. So here the example is invoice class is responsible for computing amount due. To compute the amount due, we need the information of a line item. So this is then completed a CRC card. Self-check. Rule of thumb for finding classes, look for nouns. Another check, self-check. Suppose we want to write a program to play chess. Then we have two words in mind: chessboard, move piece. But chessboard is good for class, but move piece is not, because move piece is not a noun. But move piece could be a responsibility, a verb that takes action on chessboard. So a move piece would be a good candidate for a method in chessboard class. Suppose the invoice is to be saved into a file. What would be collaborator in a saving file? We need to use a print stream object to actually save into disk file. Another self-check. Looking at the invoice, what is likely responsibility of a customer class? Customer class is responsible for producing shipping address. What do you do if a CRC card has a 10 responsibility? Here 10 is not absolute number, but here the questions, the idea is that if a class has too many responsibilities, what do you do? First try will be reword the responsibility excuse me, considering that you have given too many details, then you can just write in higher level so you can reduce the number of responsibility list. If that is not possible, then next choice is separate the class into multiple classes. Once we have identified all the classes, then next step is we are going to find the relationships among classes. Those are three primary relationships we are going to use in our class: dependency, aggregation, and inheritance. So we have studied a little bit about dependency and inheritance already. Aggregation is another relationship, but a special case of aggregation is called composition. So we are going to talk about that later. So what is dependency? Dependency is when a class uses another class. So formally we say it's knows about the class or uses a relationship. UML diagram, we use a dashed line with a line arrowhead. So here the UML diagram says a cash register class uses a coin class. So that's called a dependency. So if you draw full UML diagram with a dependency, then as you can easily see, the left one and the right one, the left one is not good design because there's too many dependencies. So minimize dependency as much as possible is a good design. The reason is that if you have a high coupling, it's like dependency, then if you change one, all dependent ones should be changed as well. So the effect of change is not confined regional locally, but it could be propagated to many classes. But if you do like this low coupling, the effect of change is confined in minimal local areas, related ones. So low coupling is always a good design. Next relationship is called aggregation. Aggregation is also known as a has a relationship or ownership relationship. What it literally means is one class owns another one. So for example, between two classes of quiz and question, to make up a quiz, you need to have many questions. So the typical situation is a quiz has many questions. UML diagram, we use a solid line with a diamond at the end. The diamond is located, placed at the owner's side. So here, this UML diagram says a quiz has a question, not question has a quiz. So be careful about the diamond, location of the diamond. When you find aggregation relationship, ownership relationship, and then when you define class, then typically you will have something like this. Since the quiz has questions, so quiz class will have question objects as a instance member. So that is a correct representation of aggregation relationship when you define classes. So aggregation, a car has a motor, tires, and so on. Then we say between car and motor or tires, it's an aggregation or has a relationship. Inheritance is a subclass, superclass relationship in general between more general class, which is superclass, and the more specialized class relationship. So another word for that is a relationship. So we say every truck is a vehicle. So truck is a subclass, a vehicle is a superclass. But we do not say every vehicle is a truck. That is logically incorrect. Sometimes inheritance is inappropriated when has a relationship, has more aggregation, make more sense. For example, between tire and circle, you may view tire as having two circles and then have some width which is connecting two circles. Or you may view as a tire is a special case of a circle which has some width information. So if you view tire as a special case of a circle with additional information, then it becomes a more specialized class. So it could be inheritance, like a tire is a subclass of a circle. But if you view it differently, tire has a circle as a boundary, then we have a aggregation relationship. So depending on the context, we could use either way. So I don't say one is the absolutely correct, the other is absolutely wrong. But depending on how you want to use them, you could go either way. But if especially if you are going to use a polymorphism requires inheritance, so you may view tire as a special case of a circle, so you could establish an inheritance relationship so that you could use a polymorphism later. So inheritance is discovered, then you would use extends to specify the inheritance relationship. So UML diagram, solid line with a triangle head, it's inheritance. So this UML diagram says a vehicle is a superclass of a car. The car owns or has a tire. That's what this UML diagram says. So here is a summary of a UML relationship symbol. So solid line with a triangle arrowhead is inheritance. But if you use a dashed line instead of solid, then the superclass is not regular class but interface type. Then we use a dashed line. Aggregation, we use a solid line, and then at owner's side we put diamond. In the dependency, we use a dashed line with a line arrowhead. The one at the arrowhead is the one being used. So self-check question, cache register tester, we had in earlier chapter, the dependency you can find. The cache register tester uses cache register class, coin class, and system class. Then we find the dependency. The question and the choice question in earlier chapter, which is a subtype and supertype, we have used it that way. So let me skip some of those self-check questions. So why do you want to minimize the coupling? Because we don't want to have some change propagated to many other classes. We want to limit or confine the changes as locally as possible. If messages are stored in the mailbox, then UML relationship is aggregation or ownership. So mailbox has messages. Another interesting situation is as follows. So suppose you want to create a library system to keep track of books checked out by whom and so on. So between a book class and student class, what would be the appropriate aggregation or ownership relationship? Is that book owns student or student owns book? Well, it depends on the situation. So not one is absolutely correct and the other is absolutely wrong. Suppose if you want to know who checked out what books, then student has books is a proper relationship. But if you want to know how many students checked out a specific book, then better relationship is a book aggregates students. So depending on the situation, how do you want to set the relationship is different. UML diagram, if you want to specify class name only, we have only one single box. But if you want to do more with the attributes and methods, then it should be partitioned like this. So the top partition you give a class name, and then next part you give attributes. Attributes are instance variables of the class, and then methods or behaviors comes in the last partition. And then you can give additional information on UML diagram. It's called the multiplicity. So here the example is a customer owns a bank account. Then we want to say customer may own one or more unlimited number of bank accounts. If that is the relationship, then we put multiplicity information over here. So dot dot, only two dots are range representation. So one or more means one dot dot star. Star means unlimited. So 0 or 1 is 0 dot dot 1. So one single number is exactly the number. And then we have another very general relationship called association. So association is to say that between two classes there is some relationship, but that relationship is not composition, not aggregation, not inheritance, not dependency. None of the relationship we have studied so far, but somehow they are related. That is called the association. Association is just a simple general relationship. So for example, between bank and customer, this is not a bank account, so none of the specific relationship makes sense. It's not dependency, not aggregation, not inheritance, but they are related. So what's the relationship? What you find is that bank serves customer. So relationship specifically is a serves. Then how do you put that in UML diagram? So draw a line and then put the label of the line, which is a specific relationship. So this is a service, but that relationship, like a service, has a direction. So bank serves a customer, then you put arrow to specify direction. But some relationships, you may not have direction, then you don't put arrowhead, just simply put solid line. So what it means is that association is just a general relationship under which we have a specific relationships like dependency, and then we have aggregation, which is a ownership relationship, and then inheritance. So in UML diagram in this course, as you find, if none of these three specific relationship is discovered, but there is somehow their relationship, then we call association. Of course, aggregation is another very specialized or specific case, which is composition. In next slide, we are going to talk about that. So this is a composition, which is a special case of aggregation, which means that ownership is exclusive. So instead of blank diamond, we put blackened one. You fill in with a black color. That is a composition. Meaning is that the bank owns a bank account exclusively, not shared by any other object or class. So that's called the composition, special case of aggregation. So aggregation then means that owner has something but that could be shared. That's aggregation.